Hello guys, welcome to Code Studio. In this session, we will discuss about support vector machine algorithms. Okay, so it is one of the machine learning algorithm which can be used to solve the classification and as well as the regression problems. So let us understand what is SVM. So let's suppose we have a classification problem, okay, where we have a positive values that is a blue observation and the negative values that is green observations. Okay, now we if apply a SVM model on these points to classify, then see what will happen. So basically it will try to draw a line like this, okay, to separate these points. Now we may have a question like based on what are the input points it will draw a line like this, okay, because it can draw a n number of lines to separate these two points, right? I mean like this. So basically these dotted lines, okay, also can be used to separate these points. So now we have to know that based on what values it basically decide this line. So let us see in the next graph. So basically SVM tried to draw a line which has a maximum marginal distance between these nearest points. So basically these nearest points are called as a support vector, okay, and hence it is called as a support vector machine. Basically for a best SVM line, okay, it will try to maintain the maximum marginal distance between these nearest points, okay, and hence we also call this the dark red line as a maximum margin hyperplane, okay. And I also can say these points are linearly separable, right, by these linear margin lines, right. We can also have a non-linear the separable points, okay, like these. So basically I have a two axes, okay, x and y, okay. So now these data points are are placed like this, okay. So basically these points are non-linearable. I mean these are non-linear separable. So how to separate or classify these points using SVM? To separate these points, so basically we have to use a parameter called the kernel, okay, in the SVM models. So what is the use of kernel parameter in SVM? So basically kernel parameter is used to convert or create a low dimensions to high or more dimensions, okay, which can help to separate these points. For example, see this. So let's suppose for this in this example, okay, kernel will create a new dimension called z, which is equals to x to the power 2 plus y to the power 2, okay. And if draw these points on the x, y and z axis, okay, graph, these points can be separable with this red line. I mean to say, if the the observations or the points are non-linear separable, then using a kernel parameter with the SVM model we can classify, okay. So this is my Jupyter notebook, okay. I already downloaded the iris dataset, so I have the iris dataset here, okay. So let me open the Python shell. Let me create a data frame to read the dataset. Let me check the basic data structure of this data set. Okay, so this is my data set, okay, where I am having input features like sepal length, sepal width, petal length, petal width, and my output is the species. Now let us see the shape of this data set. So basically it is having a 150 rows and 5 columns, okay. So let's start with the data pre-processing activities. So first step would be finding the missing values. Okay, so for that either you can use info or the isnal method. So from this info you can see the other information also, like what are the column names, what are the type of these columns, how many non-null values are there. So it seems like there is no missing value because all 150 records I can see these are the non-null. Now we will see if there is any categorical column. So in our data set we could see the output column having a categorical value, so we have to convert this. So before that we'll see what are the unique values it has. It's a species, right? So So basically it has three unique values. Okay, so we can apply label encoding technique to convert these categorical values. Okay, for that, we can have a different approaches. So like, using the replace function also can convert these categorical values into the numbers, or else, we can also use the predefined libraries. So in this session I'm going to use a predefined library called label encoder, okay, to convert these categorical values. So here is the library basically. So sklearn.preprocessing, okay, this is my class. Okay, so let me create a object for this. So here is the object. Now I'll try to create a new column to hold the numbers for these categorical values. Okay, so for that I'm creating a new target column using a fit transform method. Okay, we can convert or we can encode the categorical values. So let us see now. See, these got converted. Now to understand, the classification problem, what we will do, we will try to, draw these observations on a graph, okay, and see, whether we can see some, classification between these, the target values or the, the iris flower types. To see the classification, what I'll do, I'll create three new, data frames based on the iris flower type, okay, and we'll try to plot those points on a graph. Okay, to plot a graph, we have to import the library called matplotlib. Okay, and let me create a three data frames, bf01, so I'm creating a data frame to hold the data points of this species, okay, citrusa. So let me run this. Okay, similarly I'll create two more data frames. So this is the command. Now we'll draw a scatter plot. Okay, so we have a method called scatter. Okay, in this another scatter method, we need to pass only two dimensions, I mean the two features only. So what I'll do, I'll go with another petal length and petal width. Okay, and based on this I'll try to see the points and the classification difference. Okay, so first point, okay, let me give the color and the marker. And also let me give the axis values, I mean the labels x. Plot show. Okay, so let me draw the the similar graph for other data frames also. Okay, what I'll do, I'll just copy this. Okay, so basically it will be 2 and 3. Let me change the colors and markers. Okay, so let us run. So from this graph you can see, right, these observations are classified. I mean we can classify these observations, right, by drawing the line between these points. Okay, so now let us try to implement the SVM model on these points. Okay, so first of all we have to split this data set into features and labels, that is x and y variables. So here is the command to create a x variable. Okay, so I'm just dropping the species and species target column. Now next one would be my y variable. Okay, now let me split this x and y variable into the train and data train set and test set. So here is the basic command. Okay, uh, okay. So we are done with the the data set splitting into the train and test set. Now we can implement the SVM model. Okay, to implement the SVM model, we have to import a library called sklearn.svm, and the class would be SVC because we are trying to solve the classification problem. Okay, so from sklearn.svm import SVC. Now create an object. Okay, so let us see what are the arguments it has. So it has basically so many arguments. So basically this was the the kernel parameter, okay, which is used to solve or classify the non-linearable the separable observations. So we will leave this as default. Okay, now let us train this model. So using fit method we can train this, right? So x train and y train. Okay, now let me check the score of this model because the model has been trained now. So using score method we can check the accuracy. Okay, so basically it is 96%, right, which is pretty good. So okay guys, so this was all about SVM model. I hope you understood how to implement the SVC model. So that's all for today's session. If you like my video, please click on like button and subscribe our channel. Thank you so much.